Hello, today I'm going to talking about jump gang 2. And this question is very popular. This question is got asked by many big tech companies, so I think you need to prepare if you like it. And now let's quickly go through this question. You were given a zero-index array of integer nouns of names n. You are initially partitioned at nouns 0. Each element nouns I represent the maximum length of a forward jump from index I. In the other word, if you are at nouns I, you can jump to any noun I plus j, and where it's the names and I plus g less than n. Okay, return the minimum number of jump to reach last index. The test case are generated such that you can reach the last index. Okay, so here say there is the given array, and the output is 2. Explanation: the minimum number of jump to reach the last index is 2. Jump one step from 0 to 1, then 3 steps to the last index. Okay. Now let's quickly go through this question. Okay, 1 second. So here 2, 3, 1, 1, 4. 2, 3, 1, 1, 4. So we know we always add the first index. The first index is 0, right? 1, 2, 3, 4, 5. So in this question we can use the dynamic array. So for example, now we are at here. We are the person, right? How to person? Yeah, it's just person. Okay, just maybe it just makes point arrow here. Okay, now, so we are here. So we need to do one thing. We need to get how many steps we can jump. So we know the current index plus the current value 2. We got 2. So here, the minimum jump, we can minimum jump is 1. Maximum jump is 2. So it should be in this range, 1 and 2. Right? So here, so we know we can jump to this index and then this index, right? Now here, so here we have counting, the counting variable. So I use the C represent counting. Okay, so we start from here, and we start we add here initially. So if we got this range, how many steps we can jump, we here should be C should be increased by 1. So here we need to update it. Now it's C equal to 1. Now we know we have one we have 2 position we can jump. So now here we do the same thing. We need to get the 1 plus 3 and the 2 plus 1. Okay, 2 plus 1. Now we know here 4 and the 3. Now if we need to finish this, we need to draw on the both and comparing which one is bigger one, and then we pick the bigger one to draw to next part. Now we know here is bigger one, right? So when we finish here, when we point the pointer here, we need to tell the people which one you need to jump. We know you can jump 4. 4 is bigger one, right? 4 is bigger. So the 4 means is index 4. 4 means index 4. So you can start from here, jump to index 4. We know index 4 is not in there, right? So you just comparing which one's bigger. bigger one means it's forward, right? We can move forward. So just use this way. Or we can maybe 1 5 in the 6 1. Okay, now we know here we jump to 4, right? So we know comparing these two, we know 4 we can index 4 is more further. So we need to pick this one, and then now we do the same thing here. Now we're just comparing these two, right? Now we know here can jump to the index 4. Now we just do the same thing here. We need to add this one. Here's 2, right? 2 plus 1. 2 plus 1 is 3. Now also can jump to here, right? 3 plus 1 is 4. And 4 plus 4 is 8. So now when we get this one, we need to increase the count by 1. So we already drawn 2 times. Now we're just comparing which one is bigger. So when we hear this, we start from here, right? So here we had 2 positions we will jump here, and then now when point the pointer here, we need to update what is next jump. We need to pick a bigger no, not miss a bigger jump, right? So here we just compare these 3. We know A is bigger. We can go further, right? Because we can go to the last in day. So we just pick a maximum jump like that. Just I think it's pretty simple to understand. Now I start coding up. Now here we have count. So we need to return count. Now here we have next, right? Next jump. And now we have maximum. And we start from I equal to 0 and now so we here should be minus 1. Now we just comparing maximum I plus I, right? Because we need to calculate what is the next jump. We start from here, and then if next equal to I, okay, we know we need to pick a bigger one. So we already using the math method. Now next to be math, right? The count purpose. And let's see what happened here. So submit it. So okay, so you can see, because on the test case, the time complexity is just O(n) because I just go through each element one time, and the space complexity is constant time because I didn't use extra memory. So thank you.